All right, so we're primarily going to learn some new stuff today. We're going to need your reference sheet for sure. We're going to be looking for half and double angle formulas. But in addition to that, we need to go back and do a couple things from yesterday. Yesterday, we did not finish the notes. Towards the end, there were some on solving that we didn't get to. So I think these would be on 6B maybe. How about a random warm-up for me? Can you find on your trig reference sheet something that says, whoa, I don't know where that came from. Something that says sine, cosine, plus cosine, sine. So on the back of the reference sheet, sine, cosine, plus cosine, sine is sine of A plus B. And what are the A and the B in this particular example? So you'd have the sine of 20 plus 10 or the sine of 30. And then if you quick flip your reference sheet over, the sine of 30 is actually 1/2. Okay. One more. This is tan plus tan over 1 minus tan tan. What would that be? Tangent of A plus B. And what numbers are we going to put in there? Okay. Anybody got a calculator handy? What's 1/9 plus 5/36? Yeah, if we made this 4/9 and 5, oh, I'm sorry, 4, that's a 4. This would be a 36. 36, we'd have 9 over 36, which would reduce to what? So the tangent at pi over 4, yes, we have square root of 2 over 2 divided by square root of 2 over 2, which would be 1. All right, those were a quick review of that idea. Now, we did some verifying yesterday. Do you need me to do another one of those? Okay, this is number 10 on your notes, so you might be writing this down. We need to expand this side so that we can simplify it down to look like this. And on the quiz, when there's one of these questions, I did kind of give you some blanks and hints. It says expand, okay? So what is this going to expand to be if you call this A and B? Sine A plus B would say sine A, okay, what's A? 270 times cosine B, which would be theta. Do you need a reference sheet? There you go, just use that today. Yep. Plus, then it goes cosine 270 sine theta. Did I get that right, guys? Okay, then what do? Do you remember? My hint on the quiz is after you expand to evaluate what you can, which of those can we evaluate on our unit circle? Sine 270 is -1, and the cosine at 270 is 0, right? So what happens to all that? This is 0, and this is just negative cosine, which we were supposed to get equal to negative cosine. Okay? So those are some of the easiest proofs of all. Any questions about those? And again, on the quiz, I did give you some hints because I think when you just look at it, it's tricky to think what you're supposed to be doing. All right, what we didn't get to yesterday were these solve questions. These are solve between 0 and 2 pi, and they're kind of painful. All right, real quick, somebody help me expand this and expand this. Now, the first one, when we put this in, expand cosine A minus B. Cosine A minus B is going to be cosine times cosine. Hope you're writing this down, guys. This was from yesterday's notes. And when it was minus, it's actually plus sine sine, right? Anybody lost? I took the blue sheet or the reference sheet, and for cosine A minus B, it says it's cosine times cosine plus sine times sine, and I put those in. Okay, then there's a big old minus in here. And now I'll do this one in green, just so you know where I got those numbers. When it's sine A minus B, it's what? Sine times cosine minus cosine times sine. And in the end, this is all supposed to equal -1 from right over here. We'll worry about that at the very end. Okay. What are the cosine and sine at pi over 4? So we have square root of 2 over 2 cosine of x plus square root of 2 over 2 times the sine of x. Can we distribute this negative as we go, guys? This times this term right here would make it negative square root of 2 over 2 cosine of x. And then this times this one back here would make it plus, right? And this would be square root of 2 over 2 sine of x. Oh, I lost an x up there. Equals -1. Okay, that was a hot mess, but something happened that's good. Yeah, isn't this minus this just gone? Okay, and this plus this makes what? 2 of those. We can just write it like that for a minute. One of these messes plus one of these messes makes 2 of those. But what happens when we have 2 square root of 2 over 2? Yeah, these would multiply because everything's multiplied. So we just get square root of 2 sine x equals -1. Now are we down to something I could expect you to solve? What would you have to do? How about just isolate the function first? What are you going to divide by? So then we'd have -1 over square root of 2, which is looking a lot like negative square root of 2 over 2, which happens where? I don't think we need to square anything. Where is the sign? Negative square root of 2 over 2, and the directions way back up at the top said between 0 and 2 pi. Okay, that was kind of miserable, but that's how the last 2 homework questions are. How about I do one of the homework questions instead of another example? Would that make you happy? The last 2 homework questions last night were 41 and 43. So on this page, if I find 41 and 43, whoa, would you like to try? I think 43 looks a little trickier. What about you? Only because I know when you expand this one, the cosine of pi and sine of pi are like zeros and ones, right? So that's not so bad. You want to try this guy down here? All right, so here's 43 from last night's homework. I'm not going to talk. You're going to tell me how to write this out. If this is A and B, what do I write? Expanding this. Okay. Good job. Plus, good. Cosine. Okay. Then I'll switch colors so you know where it's coming from. But this one, we're going to have a plus. And how do we expand that mess? Anybody find it? Nope, just X because the minus is part of the formula. It's what makes this a minus here. Okay, and it's all supposed to equal 1/2, which I totally ran out of room to write. Okay, so let's see, does something cancel? Here's a negative cosine pi over 6 sine x plus a cosine pi over 6 sine x. Gone. Now, this is just like the one we just did. What happens here? Yeah, there's two of them. I guess we should have evaluated first, but it won't matter. We can evaluate now. What is the sine pi over 6? Let's substitute that in sooner rather than later. Oh, pi over 6, the sine is just 1/2? Well, that's a nice moment, because what happens? Yep, this 1/2 of 2 is just 1. So we're left with the cosine of x equals 1/2. I'm going to flip back and make sure the directions. But the directions said 0 to 2 pi with square brackets on both, in case we need to know that. But where is the cosine 1/2? That's all we need. X equals pi over 3 and 5 pi over 3. Okay. Honestly, don't think I put one of those on the quiz. But you should now be able to do the rest of that homework from last night in case. All right, I'm ready to switch. Anybody need more time on that slide? Everybody okay? All right, now I'm going to talk about today's lesson, which is 5.5. You definitely need your reference sheet in front of you because we are doing double angle relations and half angle relations. If you look on your reference sheet, like the whole bottom third of the page is taken up by these on the side that doesn't have the unit circle. Do you see all those double angle relations and half angle relations? They're long and complicated, right? Everybody see where they are? All right, so the double angle identities, this is the one that Miss Gupta says you just need to memorize. This one's super important apparently in calc, okay? The sine, anytime you have the sine of 2 theta, you can replace it with 2 times the sine times the cosine, right? The cosine, now that was for sine 2 theta. Let me highlight that. Okay, that was for sine of 2 theta. Cosine of 2 theta, whoa, what's going on over here? We have 3 different versions, okay? If you have a cosine of 2 theta, you could trade it for a cosine squared minus sine squared. You could trade it for a 2 cosine squared minus 1, or you could trade it for a 1 minus 2 sine squared. There are 3 different trades. Most of the time, there's going to be one that makes more sense than the others, but that's what you have. 3 possibilities. Okay, and again, these are on your double angle relations. Tangent of 2 theta, okay, has one trade here, but I also need you to know that you could use the sine of 2 theta over the cosine of 2 theta as a trade. Does that make sense, guys? Tangent is always sine over cosine. Okay, so I'll tell you when that's important in a minute. It's going to just make things easier sometimes if we just use that idea. All right, so this is a question like you would see on a quiz. It says, given the sine is this, and you're in this quadrant, find all of these things. So you're going to draw, and then you're going to evaluate by plugging into these double angle formulas and end up with some lovely things at the end, like those fractions. I'm not going to go through that one. You have it worked out on your sheet. I'm just going to do one with you, okay? So on your notes at the top, you might want to write this one just to remind yourself could also be 2 theta over cosine 2 theta. Yep. Is that not what I told you to get out? 7? Okay. Yep, no, you're good. I thought I was going crazy. Everybody good? All right, so you have this one. Oh, you don't have the one I just did. All right, anyway, we got it. The sine is 1/4, and it says between 0 and 90, so that's telling us the quadrant. It's in quadrant 1, right? How do I label my triangle if the sine is 1/4? Because if you can't do this, you're really in trouble. Sine of theta is 1/4, means opposite over hypotenuse, or y over r. Yes? No? Can everybody do that? Okay. Now how are we going to find this x down here? And this is what scared me, guys. On the quiz, some of you can't do Pythagorean theorem right. The Pythagorean theorem says you take the two legs squared, right, and add up to the hypotenuse. So you'd have x squared plus 1 squared equals 4 squared. What's that going to be? I shouldn't need to spend a lot of time on that. No. Square root of 15. Because 4 squared is 16, minus 1 is 15, and you can't simplify ahead of time. You have to do the squareds. Okay. Square root of 15 goes here. Now, okay, so what did we find out was the cosine? Of this particular picture, the cosine is simply adjacent over hypotenuse, or square root of 15 over 4. Okay, now it asks us to find sine of 2 theta. That's the one you should memorize, hopefully. I'm not going to take your sheet away from you, but the sine of 2 theta is 2 times the sine of theta times the cosine of theta. So if I made this angle twice as big, okay, I would have an exact value for that new angle by taking 2 times the sine here, which is 1/4, times the cosine, which is square root of 15 over 4. Then I have 2 over 1 times 1 over 4 times square root of 15 over 4. On the top, I get 2 square roots of 15. On the bottom, I get 16. And then what happens? 2 16ths reduce to 1/8. So we get square root of 15 over 8 as our reduced answer. That would be the sine of an angle twice as big as this one. Everybody good? So we're going to try this one. This is telling me, guys, I still have students who don't get this, but this is saying on the interval pi to 3 pi over 2. Look at your unit circle. That's just telling you it's in quadrant 3. Is everybody good with that news right there, that little piece? So in quadrant 3, how am I going to make the tangent 4/3? Opposite and adjacent. Where is the 4 go? Yes, on the up and down here. And where does the 3 go? Okay. What do I need to remember? There's a reason they told me I was in this quadrant. Yes, these both need to be negative, don't they, in this quadrant? I went left and down. Okay. If I do Pythagorean theorem, -3 squared plus -4 squared is 25. So R is 5. I was taking it for granted that you knew how to do this, but I got people who are messing up Pythagorean theorem. So now we're supposed to find 3 different things. The sine of 2 theta, the cosine of 2 theta, and then the tangent of 2 theta. Okay. What's the trade we're going to use to help us for sine of 2 theta, guys? 2 times the sine of theta times the cosine of theta. All right, this is not as hard as it looks. All we got to do is substitute in values. So we're going to have 2. What is the sine of this over here? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, this is a 2 over 1. So what do I get all the way across the top? 2 times -4 times -3. 24. On the bottom, 1 times 5 times 5. All right. The angle that took us all the way around to there, if I doubled it, it would have a positive sine of 24/25. The cosine of 2 theta, there are 3 choices. Which one would you like to use? It does not matter. There's questions just like this on the next quiz, so it would be a good idea to be awake and doing the notes and paying attention here. Which one would you like to use? It doesn't matter. There's 3 trades there. Doesn't matter. They're all going to be equally. Okay, cosine squared theta minus sine squared theta. All right. So what was the cosine again? -3/5, and it says I have to square it. And then I'm going to subtract the sine squared. What was the sine again? Okay, what happens when you square this one? (9/25), right? Everybody good? Minus, what happens when you square this one? 16/25. What's 9/25 minus 16/25? Okay. Now, do you remember how I said there's a trade? Because the tangent one looks like this, right? It says 2 times the tangent of theta over 1 minus the tangent of theta squared. That looks like a bunch of work to me. But do you remember what I said the option was? Sine over cosine, because we already found those, didn't we? So the trade for this that we could use is the sine of 2 theta over or divided by the cosine of 2 theta. Well, we already know those numbers is my point. The sine of 2 theta is 24/25, and the cosine of 2 theta is -7/25. So what are we going to do then? Whoops, it was divide. I want to make it multiply, so what do I have to do? Yeah, so I have 24/25 times 25/-7, which will, whoops, if I could write, which will be, can I cancel those 25s, guys?
Yeah.
So I get 24/-7. Was that way easier than trying to put this in and calculate it? Yeah. So this will be on the quiz, but I will likely only ask you for either the sine 2 theta or the cosine 2 theta, okay? I'm not going to make you do all of them, because if you mess one up, then you're in trouble, right? So the second thing you can have to do with these is use them to solve an equation. So these are the power reducing identities that are on your notes. Okay. They are on the trig reference sheet or not? What does it say? Power reduce. Oh yeah, they're on the left. Look down the side on the bottom, very bottom left. These first 2 are on your sheet. Do you see them at the very bottom of the left-hand corner on there?
On the front?
Nope, the back. It says sine squared equals and cosine squared equals.
Oh, yeah.
They're right under the double angle relations. Okay. Rarely use these. Okay. But I did put them on there. They can be used to help solve equations. I doubt we're going to use them. But they are on there. Tangent one is not on there, but you're good. All right. I am going to solve this equation. You have this on your notes? Underneath this, maybe? Do you have this one? Nowhere? Not worked out for you or anything? Cosine squared minus 2 cosine, or cosine 2x equals 1/2? All right. Well, I'm going to do a quick anyway. I think it says plan ahead which trade would make the most sense. I'm going to trade something for this. Now that means I'm going to still have this in my equation. So is there one of the trades for cosine 2x that has only cosines in it, cosine squareds? Look on your sheet. What are the three options for cosine 2x? Cosine squared minus sine squared, 2 cosine squared minus 1, 1 minus 2 sine squared. Since I'm going to have a cosine squared left, which one makes the most sense? 2 cosine squareds of theta minus 1. Okay, I already had this cosine squared. I'm bringing down from up above. This I traded. It's supposed to equal a half. All right, real quick, little algebra manipulation. So I have cosine squared minus 2 cosine squared. Okay, I have x's and thetas. Sorry about that. If I distribute that negative back here, I get a plus 1 equals 1/2. Okay, now what? What is cosine squared minus 2 cosine squared? All right, could we subtract this 1 over here? So we'd have what? Negative 1/2. Then we still don't have this isolated. Change signs on both sides or divide both sides by negative 1. Everybody okay? So we'd have the cosine squared equals, that's supposed to be a 1, 1/2. All right, if I square root both sides, what do I have to remember? Whenever I square root, I get plus or minus. Okay, square root of 1/2. Well, square root of 1 is 1, square root of 2 is square root of 2, which simplifies square root of 2 over 2. Okay, how many places does that happen in this interval, 0 to 2 pi? 4 places. Real quick, tell me where those 4 places are. All right, if I wanted to check that there were indeed 4 solutions that worked, can someone read me? Oh, you don't have it, do you? The original equation there was cosine squared minus cosine 2x, right? Cosine of x quantity squared minus cosine of 2x. Is that what it said? Okay, and it was supposed to equal 1/2. Just going to put a 0.5. Real quick, I'm going to do a zoom trig. And I hope I'm in radians. Looks like it. Okay, if I actually changed my window here, just kidding, I don't want second, to 0 to 2 pi, how many points of intersection am I seeing? That's what I want to know. Do I have all the solutions? Does it look like there should be 4 points of intersection? Okay, because if there hadn't been, then we would have figured out where we lost an answer or gained an extra answer. All right, I forgot to put these on your actual notes, but do you see the half angle formulas on your reference sheet, okay? They're nasty, right? Sine of theta over 2, cosine of theta over 2, tangent of theta over 2 has 3 possibilities, but there's actually one that's even better than any of these 3. The tangent of theta over 2 would be the same as the sine of theta over 2 divided by the cosine of theta over 2. That would be good because if you've already calculated the sine and cosine, then you can just put them over each other. What does it say there? Yeah. Oh, this is the one we like to use most, maybe it says, if you're going to have to do a problem in a minute. You might be looking to use this one because the denominator has a single term. It says, watch out, that one is probably the nicest because the denominator has a single term. The plus or minus in front of the first 3, these 2 and this one, are determined by what quadrant the angle is in. Okay? you have to figure out, is it plus or is it minus? And I'll talk you through that. All right. It says to determine whether it's positive or negative, you will have to determine what quadrant theta over 2 lies in. Oh, lovely. Okay. They want us to do an exact value question, and I did not put this on a quiz, but what is 22.5 half of, guys? Okay. So if we had to do the sine of 45 over 2, this won't take that long, I hope. How are we going to expand that? So we're going to use sine of theta over 2 equals plus or minus the square root of 1 minus cosine over 2. Everybody see where I'm at on the reference sheet? Okay, so this would become plus or minus 1 minus the cosine of, what did we put in for theta?
45.
45 all over 2. All right, what's the cosine at 45? Yep, now you want to cry, don't you? Okay. The plus or minus part out front. What quadrant is 45 in? 1. If I cut that in half and make it even smaller, it's still in quadrant 1. So while I'm in quadrant 1, what is my sine value going to be? Positive. So this is just going to be a positive. We don't have to worry about that part. All right. This is nasty, and I didn't put one like this on the quiz, but does anybody remember how we get rid of complex fractions? Multiply by the common denominator. What is the common denominator? 2. So if I multiply top and bottom by 2, so 2 times 1 would become what? Okay, 2 times the square root of 2 over 2 would just be square root of 2. And on the bottom, I'd have 4. Why is that good news? Because the square root of 4 is just 2. The square root of the top I can't mess with. That's the actual answer. All right, are those really, really ugly? I didn't put them on the quiz, so I'm going to be done with those kind. Is that all right? There might be one on the homework. You can ask about it tomorrow if there is. They're just disgusting. All right. Oops, don't cancel, don't delete, don't do anything. All right. We're going to go ahead and try to solve this one. This is number 4. You have this one? This is equation solving. Okay. Whenever you see a double angle, you're going to have to trade it out because we don't know how to solve double angles unless we can isolate them, because then we could use our giraffe math from yesterday. We could use U substitution, it's called. But can't isolate this, right, without dividing by cosine, and that's illegal. So I need to replace this with something. What can I replace it with, guys? There's only one choice. 2 times sine times cosine. Okay. Any ideas what we should do now? My first thought was, well, we have a cosine times a cosine, that's a cosine squared, right? And we could write that, but the bottom line is, isn't this all multiplied?
Yeah.
So the only way to get 0 is for what? Yeah. So the cosine could be 0. 2 could be 0. Maybe not. The sine could be 0. Or the cosine could be 0, which we already have on our list of possibilities, right? If you'd squared it, it's fine. Cosine squared equals 0. The only way that's true is if cosine is 0. All right, so now between 0 and 2 pi, where can this happen? Cosine could be 0 at 4. And the sine could be 0 at 0, pi, 2 pi. But do I want to include 2 pi? Always with the funny directions here. This one has a parenthesis, so no. Now, I could graph this to see if there were 4 places, okay, that it hit 0. I'm not going to. I'm going to keep going. What? That's it? Yep. We could. The best, fastest way to check would be to graph to see if there's 4. Somebody read me the equation. If it's a quiz, I would check them just to make sure that there aren't some that don't work. What is it? Sine 2x. Okay, my window is already set up for 0 to 2 pi. The question was, where does it hit 0, right? Because it was supposed to equal 0. So there was one here, 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 and we said 2 pi, but remember we couldn't include it. So there were 1, 2, 3, 4. We found them all. Okay? Yeah, always good to double check. All right, worksheet 7B. This is practice, and you're going to have to finish 7B for homework. So whatever we get done is part of your homework, okay? So let's go here. What is this telling us right here about where we should draw this? Right? Pi, 3 pi over 2. So it's in quadrant 3. Then this is telling me how to label my triangle. Where should I put those numbers? Okay, is this an easy one that you know? Okay. Everybody's good why it's negative. Did me do Pythagorean theorem to show you it's 4? You believe me? Okay. We have a ton of work to do. It says we have to find 6 different things. Yep. The hypotenuse is always positive. It's like, it's a circle, so it's the radius, it's a distance. In my mind, that makes sense. But the other issue is that these are directional, and that's not going to be, okay? Yeah. I don't have a very good answer for that. Okay. Sine of 2 theta, or 2 alpha, I guess this is an alpha, but what's the formula for that? 2 times sine times cosine. Okay, let's substitute in some numbers from over here. 2 times the sine, which is negative 3/5. They told us that. You know what? This would go faster if we wrote down the missing ones. They told us sine right up here. Cosine is going to be what? So we can just substitute it when we need it. Negative 4/5. And tangent, if we need it, is going to be 3/4. Okay. That way when we need them, we can just write them down. We don't have to keep looking at the little picture. So 2 times sine times cosine, and the cosine we said was negative 4/5. Okay. What is that going to simplify to? Use your calculator if you need to, guys. It is 24 over 25 because it's 2 times negative 3 times negative 4. And the bottom is 5 times 5. But feel free to use your calculator on these. It will do them, as long as you put the parentheses, do math, enter, enter at the end. All right, cosine 2 theta. Pick one. I'm going to use the first one again.
Yeah.
Is it cosine squared minus sine squared? Okay. So if I plug in values, what is the cosine? And I'm going to have to square it. And the sine is negative 3/5. Remember, you have to square them and then worry about the minus. 16 over 25 minus 9 over 25 is going to be positive 7 over 25. Okay, the tangent formula is real ugly. Do you remember my shortcut? It's sine of 2. We could do it with the big long formula.
No.
Okay, but it's sine of 2 theta or alpha over cosine of 2 alpha, which means we already have those numbers. It's 24 25th divided by 7 25th, which would be 24 25th times 25 over 7. These are going to cancel and we just get 24 over 7. Now, I know these numbers are like the ones we did earlier, but that's because there aren't very many nice triangles, so we use 3, 4, 5 a lot. All right, now the icky ones. The half angle ones, sine of theta over 2, okay? I don't have that one memorized. What is sine of theta over 2? Plus or minus 1 minus cosine over 2. Okay. We'll talk about the plus or minus in a second. Let's just do the insides. We have the square root of 1 minus, what's the cosine? Negative 4/5. And then it's divided by 2. Okay. You want me to show you the fractions or you want to just do it on your calculator? Okay, do the top first. Don't put the square root in because we want an exact answer. Do the top first. 1 minus negative 4 over 5 should become 13/5. Is that right or no? No, 9/5, right? 9/5. Duh. Okay, and then you need to divide by 2. Math, enter, enter. So you end up with 9/10. Everybody get that? You have to do the top divided by 2, and you don't want to put the square root in because you're looking for an exact answer. Good news for the top. What's the top? 3. The bottom is just square root of 10, so we have to rationalize and get 3 square roots of 10 over 10. All right, we still have a plus or minus to worry about. This is so hard for students to understand. What? Okay, the original angle is in quadrant 3, right? This says theta or alpha divided by 2. Okay, so our original angle was somewhere, I'm going to talk in degrees because we all think in degrees, right? Our original angle was somewhere between 180 and 270. If we take and divide that by 2, it will be somewhere between 90 and 135. Where would that be? Quadrant 2. So this is in quadrant 2. What is the sine value in quadrant 2? Positive or negative? Positive. But the cosine is going to be, so we're going to have negative square root of, and the formula is 1 plus cosine over 2. So it would be 1 plus negative 4/5 over 2, which is 1/5 divided by 2 is 1/10. So it's going to be negative 1 over square root of 10 or square root of 10 over 10. And if you went to do tangent, if you put this answer over this answer, guys, you would get negative 3. Okay, if you had negative 3 square root of 10 over 10 divided by negative square root of 10 over 10, all that would divide out and you would just end up with negative 3 for the tangent. Can the tangent be negative 3? Yeah, the tangent can be anything, right? So here's your homework. There are 5 book problems, and then you need to finish 7B. Tomorrow is work/questions day, so please come with questions.